Okay, so welcome everyone. I guess I'm audible and my screen is visible to everyone. Okay.
Yes,
Now, in this surveying two, I, along with Professor Gopinath Bhandari and Professor Ompam Devsarkar, will take this subject. So, I guess all the faculties have told you which portion they are taking. ADS sir is probably taking this setting out of curve, transition and compound, and this tunnel survey, hydrographic survey, this portion, right?
yes, sir.
And GNV sir have started the class. Which portion is GNV taking? Right. So this photogrammetry and this remote sensing, this portion is this portion GNB sir is taking, right? Okay. And I will take mainly this portion, that is electronic electronic distance measurements and principle of total station and its accessories and advantage and application. Okay. So when as from the next week we are having offline class, and hopefully when you will have this surveying laboratory, at that time also we'll have offline class. At that time, major of the instrument you will see, majority of them will depend on, majority of the practical will depend on total station. Okay, because we have lost so many theodolite and all these things, so only few theodolite we will purchase and majority of them we will purchase the total station, so that we you can learn in some advanced tools, right? So total station, if you know the theodolite part, it will be very easy to understand the total station. Okay, but total station where you don't have to even go for chaining. You don't have to measure the distance. By the total station itself, you can measure the angle as well as the distance. In the theodolite, what we are doing, we are measuring the angles mainly. The distance we are measuring by chaining, right? Or the by the principle of tachymetry you can measure also. But in case of total station, electronically you can measure the distance. So that basic principle of EDM that we will discuss today. So today will be a very basic introduction class of your EDM, that is electromagnetic distance measurements. So that is the full form of EDM. Now, you know there are three methods of measuring distance between any two given points. Say between point A and point B, we want to measure the distance. We can employ three methods. One is called direct distance measurement. Direct distance measurements. So this is the direct measurmental method, and this is done by either chaining or tape. So either by chaining or taping. The second method is called optical distance measurements, which is basically our tachymetric principle. So optical distance measurements, ODM, right? Here we have come across the tachymetry and all these things. That is basically optical distance measurements. Tachymetry is the example of this sort of measurements, right? And then there is third one, that is called electromagnetic distance measurements. So EDM, electromagnetic distance measurements. Here there is so many instruments can be there, like geodemeter, tellurometer or distomat. All this sort of instrument can be there. Geodemeter, tellurometer or distomat. Our total station is also based on this EDM principle. Now, what is the need of EDM? That we have to understand. What is the need of EDM? Okay, so that we need to understand. What is the need of EDM? Because if you go for direct distance measurement, it is unsuitable for difficult terrain. কে এটা সিনেমা না কি চালিয়ে দিচ্ছ? বিশাল মন্ডল নাকি? বিশাল মন্ডল কিছু
স্যার
বলছো?
সরি স্যার, আসলে স্যার বাই চান্স মাইকটা অন হয়ে গেছিল, সরি।
So, direct distance measurements like chaining or taping with the help of chain or tape, you can't do the measurements if the terrain is difficult. If the terrain is like this, you can't do chaining. That we know, right? So, very much difficult to do chaining in this kind of terrain. So, that is the problem associated with DDM or direct distance measurements. Now, how you can overcome that problem? We have seen that we can overcome that problem by tachymetry or optical distance measurements. There, we can obviously overcome this chaining problem because chaining we can't do this sort in this sort of terrain, but ODM we can do. But what is the problem with ODM? In ODM, you can measure up to 150 meter with accuracy. With accurately, you can measure up to 150 meter. But if you are going beyond that, there will be error. So one up to 150 meter, you can measure with a accuracy of 1 to 1000. That means this much error will be there if you are measuring up to 150 meter. So 1 by 1000 to 1 by 10,000. So this much error will be there. If you measure up to 150 meter, that is also okay. But if you go beyond that, the error will be much more. But in EDM, what you can do? You can obviously overcome the problem of chaining. Also, you can overcome the problem of ODM, that is optical distance measurements. That means you can do a very large measurements also very accurately. That means over a range of 100 kilometer you can measure and with a error of only 1 in 10 to the power 5. So you can see even you are measuring a large distance, the error is very minimum. So that is the accuracy level of EDM. That's why we prefer nowadays EDM. We can do the surveying very easily, very rapidly you can do the surveying, right? So EDM is basically a general term which is basically denote the measurements by electromagnetic waves or electromagnetic methods.
স্যার
Or
ইডিএম এর ফুল ফর্মটা একবার বলবেন একটু?
এই যে লিখে দিয়েছি electromagnetic distance measurements.
Okay,
E
sir,
for
okay.
electromagnetic, D for distance, M for measurements. Okay.
ওকে স্যার।
Okay. Now EDM we are using in general term that will be used for distance measurements by instrument where electromagnetic waves propagation will be used. Their reflection and their reception also we will use. That means what we can do that one transmitter will be there that will generate some electromagnetic wave, and suppose we want to measure the distance from A to B and one receiver can be there in B. So A is generating one wave and B is receiving that, and when A is generating the wave you can start any stopwatch or any sort of time measurement device which can just measure the time difference between generation of the electromagnetic wave and at the time when at B that electromagnetic wave will be received. Any receiver can be here. So this time difference can be measured by any device, and that can be multiplied by the speed of this electromagnetic wave. So by this method, obviously, you can measure this distance, right? So we'll come to that later on. What will be the process? Okay. So
So we can
basically,
do this by sound wave also by sonar and that system which are used in the ships and in ocean. The sonar system like that.
yes, sonar system is also used in the all these things. But here, what will happen? There will be some advancement in this technology that we will discuss later on. Okay, it is beneficial than sonar technology also. Okay,
Yeah, okay, sir.
okay. So in the EDM, mainly you have to understand that EDM mainly three things should be there. One, which will transmit or basically generate the electromagnetic waves, right? And then there can be receiver. Not only that, sometimes some reflector can also be there. What is the purpose of using reflector? We will discuss that. Okay. Now, electromagnetic waves which will be generated here, it will depends on many factors, but it will mainly depend on the electrical signals used to generate these waves. So it will depend on electrical signals. Okay. Now, basically this system developed after the use and evolution of the radar technology, which is developed in the 1939 and 45 in this time period. Okay. However, this is initially used only in the defense purpose. Later on, we have started using it in the surveying also. So in the EDM, commonly used in surveying, we normally use modulated infrared rays. Although we can use any rays, but we are mainly use modulated infrared rays. Now we will discuss the very basic property of the waves and all these things which you have studied in your class 12s also. So that part we will discuss in very brief. So properties of electromagnetic waves. So suppose electromagnetic waves which is very complex in actual nature, but we can represent an electromagnetic wave in a periodic sinusoidal wave. So like this, right? So say
Sir,
like
electromagnetic wave or electronic distance measurement as same.
what?
Electromagnetic wave or electronic distance measurement as same.
Electronic distance measurements is using electromagnetic waves.
Okay, sir.
Okay. How
Yes,
many,
sir.
that I am coming to that part. Okay, don't worry, I will come to that part. It is using electromagnetic wave. What I have told you, that one something will be there for measurements electron with the help of EDM. If you want to measure the distance, one point will be there which will generate the electromagnetic waves, and then it will go, and one receiver can be there, and by calculating the time difference and multiplying the multiplying it by the speed of electromagnetic wave, we can calculate the distance, right? So basically it is depending on the principle of electromagnetic wave. Is it clear?
Okay, sir.
Okay. So electromagnetic waves properties we have to know before we go in the detailed discussion of electromagnetic wave, electronically distance measurements. Although all of you know the basic properties, if we represent any wave in sinusoidal pattern, so if we represent any wave in sinusoidal pattern, we can term say these points like A, B, C, D, E, F like this, right? Now here A and E, these are identical points, because you know in A it is moving in this world, in E also it is moving in this world. C and A, those two are not obviously identical points, right? So A and E, these are identical points, and we know the distance between them is known as what? The distance between
Wavelength.
anyone?
Wavelength, A and E distance.
Obviously. So wavelength, right? So the waves will complete a cycle if it moves from A to E. It
স্যার
will
ওটা
complete.
সাইকেল ওয়েভলেংথ হবে না স্যার?
Cycle wavelength and wavelength obviously is the same. No, one wavelength is basically when it completes one cycle. What is wavelength? Wavelength is that what we are talking, like one cycle if it will complete, or if it the difference between the similar sort of points, right? Is it clear?
ইয়েস স্যার।
Okay. So one wavelength is the distance between A to E. Now, if you know this distance, and also if you know the frequency of these waves, if you know the frequency means how many cycles it completes in 1 second. So if it completes one cycle in 1 second, its frequency will be 1 hertz. We
Wow,
know
sir.
this, right? So if it completes f numbers of cycles in 1 second, then its frequency will be f hertz, right? Now your, if in 1 second f number of cycles is completed, f cycle is completed, then its frequency is f hertz. And if in each cycle it travels a path of lambda, then total path traveled in 1 second will be f lambda, and that is basically the speed of the electromagnetic wave. That means how much distance it is traveling in 1 second. So c is basically f into lambda. All these things you have studied in your class 11 12, so I am just repeating those parts. So c
স্যার ওটা ভি হবে না স্যার?
হ্যাঁ বলো।
স্যার ওটা তো ভি ছিল, ভি ইকুয়াল টু এফ ইন্টু ল্যামডা।
You are representing it by v.
Yes,
I am
C,
representing it by
ভেলোসিটি আই থিঙ্ক,
huh?
ভেলোসিটি
মানে
অফ
সিটাকে
ইলেক্ট্রোম্যাগনেটিক।
I am representing
এখানে
c
স্যার
as the
সিটাকে ভেলোসিটি দিয়ে দেখাচ্ছে।
ওকে স্যার।
You can write it v also. There is nothing, whatever you are assuming, that is the velocity of the electromagnetic wave. I am writing it as c. You can write it as v also. Nothing problem is there, right? Whatever, if say any object, you are giving it any different name, or someone call it by different name, there is nothing difference, right? Basically the properties, or you have to understand the basic part. You can call it v, you can call it c, that is your choice. Okay. So velocity of this electromagnetic wave that we are terming here as c, you can write it as v also. That will be f into lambda. Or we can write frequency is equals to c by lambda, or simple we can write frequency as 1 by t, because we know the if time period or time taken for completing one cycle is say 0.02 second, then how many cycle it will complete within 1 second? So obviously one cycle is completed within 0.02 second, then how many cycle it will take, it will complete within 1 second? It will be 1 by 0.02, and it will be nearly 50. So 50 or 500, then 100 by 250. Okay, so its frequency will be 50 like this. So if you know the time period, you can calculate the frequency. We know these basic relations, right? So if the frequency say is 10 to the power 3 hertz, what does that mean? Or if the frequency is 10 to the power 4 hertz, what does that mean? That means within a second this electromagnetic wave is able to complete 10 to the power 4 cycles, right? So this is known as frequency. We know what is the length traveled in one cycle, that will be denoted by lambda, which is wavelength. We know what is the period or time taken by one cycle, that will be known as time period, which will be again in second. And we know the velocity, which we are denoting here by c, that will be basically total distance travel in 1 second, which will be equals to f into lambda. Okay. So if you vary one of them, obviously others will vary. Okay. The velocity of electromagnetic wave depends on the medium also. Okay. And if if we are denoting it by c, then we know the relation is f lambda or is equals to 1 by t. Normally, we assume this speed of this electromagnetic wave as 3 into 10 to the power 8 meter per second. Although it will be near to this, not exactly this one, but near to this one. So we will take for our measurements this one. That is the speed of the electromagnetic wave. Now, another important property will be the phase of waves. So, phase of waves will be denoted by phi. Okay, it is very convenient of identifying the phi. Okay, or how much fraction of a wavelength is completed. So, if you are at A, how much fraction is completed? 0%. So here the phase will be 0 degree. If you are at B, then how much percentage is completed? If you take this as half, then then your 1/4 is completed. If your phase is 360 degree, then how much part is completed? 90 degree. So if you are at B, your phase will be 90 degree. If you are at C, you have completed half of the cycle, because from A to E your full cycle is there.
180 degree.
So if you have completed up to C, half you have completed, so it will be 180 degree. Similarly, if you are at D, you have completed how much?
270.
Yes, 270 it will be, right? And if you are at E, obviously your phase is 360, or 0 also you can write, because one cycle is completed, right? Now if you are at F, then after completing a cycle, again starting of the cycle, you have completed 1/4, so the phase will be 90 degree, like this. Okay, is this clear?
Yes, sir.
Okay, so the electromagnetic wave is known by its wavelength or frequency, because we know if the frequency or wavelength will vary, we know that is the different kind of electromagnetic wave will be. Okay, so if you differentiate between them, we know that there is long wavelength. First there will be long wavelength, then there will be medium wave, then there will be short wave, then there will be microwave, then there will be infrared wave, then there will be visible light. Okay, there also you are having VIBGYOR, that part. After the visible light you are having UV rays, then you are having X rays also. So what is the more or less wavelength? Normally if you say, the wavelength will be nearly the medium wavelength will be, which will be more than 10 square, 10 square in meter. And long wavelength, normally 10 to the power 4 comes here, so it will be nearly greater than 10 to the power 3 or like this. Okay, short wavelength, normally it will comes to more than 1 meter, that means 10 to the power 0, it is more than this. Microwaves, normally is, you can say, it will be just some fraction multiplied by 10 to the power 4, say 5 or 4 into 10 to the power 4, that much meter. So microwave length will be more than this. Infrared wavelength will be in between this and 10 to the power minus 6 meter. Then there is visible light, which will be vary for a very less. Okay, so I'm not denoting it as 10 to the power minus 7. You can write 10 to the power minus 7. Then there is ultraviolet rays, which will be up to 10 to the power minus 9 almost. And then there is X-rays. So these are the kind of wavelength. You can differentiate in terms of hertz also. So majorly the EDM principle will depend on the types of the wavelength, and majorly we will use modulated infrared rays, where the speed will be approximately 3 into 10 to the power 8 meter per second. Now let us discuss the measurement of transit times. Transit times means how much time it takes for traveling. So say we want to measure the distance between A to B. We want to measure this distance. So what we can do, at A, we can keep EDM equipments, right, which will generate the electromagnetic waves by the transmitter which is placed at A, so that the electromagnetic waves will propagate and will go. And at B there can be any receiver. So at B there can be any receiver. Now when the transmitter is generating the wave, if if any stopwatch or any watch or any time measurement device started at that point of time, and this transit time, that means electromagnetic wave transiting from this A point to B point, this time, if if B is able to measure this time, how it can measure? If you are able to start the device which can measure the time period or the time interval, if you can start that device when A is generating the wave, and if you can stop that when B is receiving the wave, if you can do that, then this time interval, the time interval can be measured. And if you measure that, if you multiply that time interval by the speed of the electromagnetic wave, obviously you will get this distance d, right? But one problem is there. What sort of problem will be there? Because you know this time interval is very less. This time interval is very less. So this time interval as is very less, nearly almost will be in the order of 10 to the power minus 6 second. So obviously it is very difficult to do these things. Okay, in the very advanced EDM instrument, even T can go below this 10 to the power minus 6. Okay, so that you can measure very smaller distance also. So what will happen, that the these T measurements will be very difficult. So for that reason, what we can do, if because no one is able to start and stop any measurement device or any clock which is present at the B. So what we can do, instead of placing the receiver at B, we can keep the transmitter as well as the receiver both at A, and at B we can keep just a reflector. So what will happen, the waves will come, then it will be reflected and reflected back towards the A. So it will be reflected back towards the A, and as at A receiver will be there, so it will receive that wave. So what will happen, that with the starting or with the generation of the electromagnetic wave and the receiver, when it will receive that electromagnetic wave, it can calculate the transit time, but that transit time will be 2 times the actual transit times. So that transit times will be actually for 2D. That means if you measure this transit times and if you multiply it by C, you will actually get 2D if this is D. Why? Because already the wave is traveling D, it is reflected, then it is coming back again. So it is traveling 2D, and for that you are getting the time interval, which is basically getting the time interval between the first wave which is generated and then which one it is receiving. So if you multiply that by C, you will get the distance 2D. So if you divide that by 2, you will get the actual distance. So this is the basic principle of measurements in in EDM. Okay. And in this sort of instrument, what will happen? You can go up to the accuracy of 10 to the power minus 9 second also. Okay, so you can go up to this level also. Now, how it will actually measure? It will actually measure 2D, which will be the distance. It will actually measure how many wavelength it has completed. So say n numbers of full wavelength it has completed, right? And some part of the also wavelength will be there which it can hit the B, say at this point or at this point, and it can hit back say like this, say this one. So it has completed one, two, then three, and then say 1.5. So 3 amount it has completed, and then it is 1.5. So it will return back how much it will complete. It will complete again 3 and again 1.5, right? So it can be not only 1.5, it can complete half only when it will go. So say 3 full cycle it has completed, or 3000 full cycle it has completed, or 30,000 full cycle it has completed, or 30,000 something 455 full cycle it has completed, and some half cycle it has completed. That means say 90-degree phase difference is there, it has completed. So when it will come back, it will again complete 30,455 and again complete half of the phase difference. So ultimately it will be half and half one. That means it will only complete a up to 180 degrees. So that can happen, total half part, 1/4 and 1/4. So that can happen. So that means 2D will be the total number of wavelength it has completed, or total number of cycles it has completed, and sum of the part cycle. So that will be denoted like n lambda plus lambda. Is it clear, this portion, or whether I will explain this part?
Sir, n lambda plus the second part.
Delta lambda. Delta lambda is the part of a wavelength which is
স্যার
not.
একবার বলেই দিন
Okay.
Yes, sir. Yes, sir. Bolden.
So suppose here is A, and suppose the wavelength is generated like this. So say this is the completed of one part, this is the completed of second part. Now suppose this is B. So here how much part it has completed? See, one full cycle, second full cycle, right? Lambda 1, lambda 2, then there is, this is how much part is completed. If this is one part, this is how much part? 1/4 part. So 1/4 part is completed. Now when it will come back to B to A dashed, how it will move? It will move basically like this. It will basically move like this. See, this is the A dashed. If I am representing A to B here, and then the wave will move from B to A here, I am representing as this as A dash. Now if I represent this in the same scale, then how it will move? When A to B it is moving, it is completing 2 full cycle and 1/4 of another cycle. Hence when from B to A again it will move, it will again complete 2 full cycle and 1/4 of the of a cycle. Is it clear? Is it clear?
Yes, sir. Yes, sir.
So ultimately it will complete 4 full cycle and half part of the cycle. So then your n lambdas, n will be 4 plus in your delta lambda, this will be lambda by 2. Is that clear?
Yes, sir.
So similarly, actually, I have taken here a very short example because I can't represent here. Otherwise, what will happen? Delta lambda will be always less than lambda. That means it is the only a little part of a wavelength or little part of a cycle which is not completed. Okay, and n is very huge number. It will be there. That means how many cycles will be completed? Say 31,535 lambda. That means 31,535 total. This much amount of cycle is completed, and then there is lambda by 2. That means half part of the lambda is completed, or lambda by 3 can be also there. That is called n lambda plus delta lambda. Is that clear?
Yes, sir. Clear.
Okay. So that is
Sir,
basically huh.
sir, what happens to the rays which are starting from A, and means at point A there is also the emitter and the receiver. So some part of the waves are received by the receiver just at the point of starting, means.
No, it will not happen because receiver can be in this side. Here the emitter will be in this side. Are you getting my point? Once it will get reflected at that time only it will get received. It can happen, right? Or that can also happen, whatever you are saying. In that case, it will measure the phase difference, and by that also it can measure. But the basic principle is that it will started at this point, and after reflection, it will get received. Is that clear?
Yes, sir.
Okay. Okay, so that's why we have represented A and A dash. Although these 2 points will be near, there will not be many difference, but we can place that in such a way that these points or these rays will be emitted in one direction and it will not be received by this. So that can happen. That is not a very big deal. Okay, that can happen. So the question is now that 2D is equals to L lambda plus sorry, L lambda plus delta lambda. Now their delta lambda, how it will be measured? It will be basically measured by the phase difference. That means in the starting, when the starting rays phase and when it will received, at that point what will be the phase? By differentiating those 2 phase, and what is the difference between them, these 2, that is phi 2 minus phi 1. If you take this difference and divide it by 360 degree, you know how much part of the lambda is completed, and if you multiply by that by lambda, you know what is the delta lambda. So in this way the machine will calculate the delta lambda. That means the starting rays phase difference, if it knows the phase of the starting rays, and if it knows the phase of the reflected rays, then it can just calculate what is the phase difference. Say initial phase is 0 degree, say the receiver's phase is 180 degree or 270 degree. So what is the not completed cycle? The not completed cycles, obviously 180 degree or 270 degree phase is completed because this is the phase difference. So 180 by 360, that means half part is completed, or 270 by 360, so 3 by 4th part is completed. That will be multiplied by the lambda, so that will be the delta lambda. Is that clear? Is that clear?
Yes, sir.
Okay, so in this way we can calculate the 2D plus 2D, which is basically n lambda plus delta lambda, which is basically phi 2 minus phi 1 by 360 degree into lambda. Is there
Sir,
any huh?
sir, I had a question.
Okay, go
Sir,
ahead.
let's say we are measuring 100 meter using this EDM technique. and some amount of delta lambda is present.
Hmm.
Can't we ignore that?
Yes, you can, but if this is because the lambda will be very less, right?
Yes, that's why.
Yeah, so you can do that if the lambda is very less, but suppose we are using say lambda equals to infrared. Infrared, we have to
Sir,
talk
for
about.
infrared, it is very less. There's like 10 to the power
Yes,
minus 6 in consideration of 100 meters.
right. So it will be in the millimeters, right? So that we can ignore. But say if the lambda is higher, at that time you can't ignore. So the machine will take care of these things. You don't have to do
Oh,
this
okay.
calculation by yourself. Okay, just
I
and
thought we had to measure that separately.
you don't have to.
Okay, sir.
You don't have to measure these things. I am just giving you the basic principle how it is measuring. You will directly get the directly get the distance. Is that clear?
Yes,
Because
sir.
we will put the value, the already the machine is built up in such a way it will measure all this time interval, it will multiply by the actual velocity, and it will give you the actual distance, not even 2D. It will give you the distance actually. Okay, so by dividing it by 2 it will give you the actual distance, so you don't have to do any calculation. I'm just telling you the basic principle how it will work. Okay.
Yes, sir.
Okay, so say your lambda or wavelength is 20 meter. For an example, just this is for an example. Okay, say your lambda is 20 meter, and say number of totally completed cycle is 6. Okay, and say the phases of the starting incident ray is 0 degree and phi 2 is 270 degree. Then calculate what is the actual distance. So 2D will be equals to n lambda plus phi 2 minus phi 1 by 360 degree into lambda. So 2D will be equals to 6 lambda plus 270 minus 0 by 360 into lambda. So here how much it will come? 270 by
135.
360. So it will be 3 by 4. If you divide by 90 degree, it will be 3 by 4. So 6 lambda plus 3 by 4 lambda, or we can say 27 by 4 lambda, right? Now if you place the value of lambda, so this is 2D, 27 by 4 lambda. Now D will be 27 by 8 lambda, so it will be 27 by 8 into lambda. Lambda is how much? 20 meter. So your D will be how much? Calculate. Calculate how much it will be.
Sir, 67.5.
So I hope you have done the calculation in the right way. So it is 67.5 meter, right? So in this way it will do the measurements. So remember, you don't have to do all this calculation. You will only get the data. You have to, this method is so fast, you have to just set the, say any EDM you are using, say you are using any total station or anything, you have to set and center it properly, and then what you will do, you will just uh, keep your reflector at the B, and when ray will generate, it will be reflected and it will come back and you will get the distance directly. You don't have to do any sort of calculation.
So the leveling of the tripod thing remains the same for
Yes,
this.
yes. And these things also you have to level properly, because if it is inclined, you can see what will be the problem. The distance measurements will be okay, but no, distance measurements also will be problematic because it will not cut at the exact positioning. Suppose you are keeping like this, so it will cut at this point. So distance measurements also will not be okay. Hence, you have to keep at these things also, uh, you have to level these things also. So how we will level? Due to these things, in the reflector also one small bubble sort of things is given. Only you have to, you don't have to do like by movement of screw or anything, you have to do anything like that. You have to keep it in such a way like this bubbles is at the center. Another camera, like we have the camera or the tripod, in those sort of things, only one small bubble is there within the water or the spirit level. So that sort of things will be there along with this, so that when you are holding that, you have to hold properly. Okay, is that clear? This centering and leveling of these things all obviously will be there. You have to do this, do that part. But we are not discussing that part because that is exactly similar with the theodolite. Okay, and that is why it is said always that if you know the theodolite, knowing total station is very easy. Okay. So is there any question? Otherwise, we are done for today.
Is there any minimum distance after that we can't measure? I mean, say m meter, minimum distance that we can measure. Distance less than m meter we can't measure. Is there any such minimum distance?
Any such minimum things is not there. Obviously, because
Actually, sir, when we are doing 2D, that in case we are assuming that distance is, we are maintaining such that the distance is greater, so that we get the right result, right?
Right.
So, in case of
Obviously.
a smaller distance,
So
2D will be also less, right?
what today I can't get you, but can you again?
In case of a smaller distance, 2D
Yes.
will also be also less.
2D obviously also will be less. If you place here, obviously it will be 2D will be less. Total distance will be this much, right?
Yes, sir.
And
Then,
as the wavelength is very less, so there is nothing sort of minimum distance which you have to measure. This sort of things is not fixed, so you can measure. Okay.
okay, sir.
Means at least you will keep it at few centimeter distance, and that also will be measurable, I guess. Okay. But for any instrument specification, that I have to look for, means that I do not know specifically. I have to look if for the different companies instrument, if they specify certain kind of distance. Okay.
Okay, sir.
And if it is a few centimeter, even you don't need this sort of instrument also, because for that you can do the chaining also, but it is not required, because you can do any measurements with EDM, because you don't have, generally we don't require to measure few centimeter through these instruments, right? Surveying is related, not in the surveying we are not performing this sort of measurements like few centimeters or like this, right? Even if it is
Okay.
1 meter also, half meter also, it will measure, not a problematic thing. Is that clear?
Yes, sir.
Yes, sir. So I'm closing today's class. I will take the attendance. Just wait.